We are going to be learning Unit 4, Lesson 20 on equivalent expressions and using equivalent algebraic expressions. Algebraic because we're going to be using some variables. Some of these things that we've done, you have done these expressions in elementary grades, especially when you were learning how to multiply. For example, look to the side here. When you were learning what 7 times 3 was in about probably second grade. Let me see if I can adjust this. Oh, there we go. You knew to do repeated addition. So you would do 7 plus 7 plus 7. And you know both of these equal 21. So we're going to be kind of doing the same thing, but we're going to be doing some variables along with it. Let's take a look at the example. If you see the example, it's x plus x plus x plus x. And how many x's do you have? 4 of them. So that's why it equals 4x. You're repeating 4 x's, adding together. If you look at the second example, we have two like variables, a and a plus a. That's why it equals 2a. You only have the 1b and the 1,3. So on the other side of the equal sign, it says plus 1b plus 1c. Now let's take a look at our examples that we're going to start with number 1. It says write an equivalent expression for each. So how many x's do we have? We have 7 of them. It tells me to multiply x 7 times because it's side by side you multiply. So I'm going to do repeated addition to represent this by saying x plus x, that's 2, plus x, that's 3, plus x, that's 4, plus x, that's 5, plus x, that's 6, and plus another x, that is 7. So if I count my x's, I have 1, 2, 3, 4, 5, 6, and 7. So 7x is equal to all those x's added together. So for number 2, we're going to do the same thing, but now we have y. I'm going to write y 4 times. So repeat addition with y 4 times. So I'm going to say y plus y plus y plus y. Now I have 4 y's. So 4 times y is y plus y plus y plus y. Now it's kind of in reverse. Number 3, they're giving us the repeated addition, and we have to write the expression that goes with this. So if I look at the answer here, we have C, or the question, we have C plus C plus C plus C plus C. How many C's do we have? Let's count them. 1, 2, 3, 4, and 5. So that is equal to 5C. Okay, let's take a look at number 4. Now, we would look at the problem, and I see I have 7 times 7. We would work that out as normal. That decimal in the middle means times. So we're going to say 7 times 7 is 49. Now we're still plussing the x in the back. So 49 plus x. You're basically just solving what you can from the expression. So I look here at number 5. I have 2 times 2, which would equal 4, but we're not going to plus b. We're going to times b. So you could do 4 dot b, or you could just write it as 4b. Side by side, you multiply. Look at number 7. 7, the beginning of my problem says 7 plus. So I'm going to say 7 plus. Now I can combine my like variables, which would be 3 of them, is 3n. So I'll say 7 plus 3n. And there is my answer. Now we're going to use distributive property to write an expression, to write an equivalent expression for each. We're going to see if we have, well, first we're going to distribute out using the property for number 7 like we practiced last week with Unit 19. So 2 is on the outside and it's side by side, so we multiply. So I'm going to share my 2 or distribute out my 2 with everything that's inside the parentheses. So I'm going to start with 2 times 3, which gives me 6x. Then I'm going to take my 2 and add it to the 6, which would be just 12. Now, what was the operation inside the parentheses? It was addition. And there is my answer. Now, for number 8 and number 9, we're going to have to kind of think in reverse. We're going to have to pull out what's being distributed. It was already distributed, so kind of like the answer that we got here is like given to us in the problem here. We have to find out what did they distribute out. We do that by finding a common factor. What is a common factor that we can pull out from 14 and 21? Well, we can pull out 1, but we would still get the same thing. So, could I maybe pull out 2? It would work for 14, but not 21. So I keep going through 3 works for 21, but not 14, until I finally find a common one, which in this case would be 7. So I'm going to pull out 7, and when I do that, I put it outside the parentheses because that's what I'm pulling out to be distributed. Now, what would be the matching factor that goes with 7 that would go into 14? It would be 2. So inside the parentheses, I'm going to have 2x plus, well, how many times will 7 go to 21? 3 times. Now, if I work out this problem, I should get what they gave me as 14x plus 21. We're going to do the same thing for number 9. What common factor do they have in number 9? What number goes into both of those? Well, 1 would go in both of them. 2 would go in both of them. But I bet the highest one I could do would be 4. So I pull out the 4 distributing factor, and I go and I see how many times can 4 go into 4, which is 1. You can write it as 1x, or you can just write 1x. Plus, how many times is 4 going to 20? It goes in 5 times. And so now I've just kind of done the problem in reverse. 4 times x is 4x, and 4 times 5 gives me that 20. Okay? Now, let's take a look at number 10. It says, write 2 expressions equivalent to 30x plus 20y. You're to come up with 2 distributive expressions that you could write that would be equivalent to what they gave us in a problem. I want you to pause the video, and I want you to come up with 2 of them. When you get done coming up with 2 of them, then you can unpause it and we'll go over it. Pause the video now. Okay, now you should have come up with at least 2 expressions that are equal to 30x plus 20y. What is a common factor that 30 and 20 share? Well, the first one that comes to mind is 2. I know that 2 can go to 30 15 times, and 2 can go to 20 10 times. I also know I could have used 5. 5 goes into 30 6 times, 6x, and it goes into 20 4 times, so 4y. Another one you could have done that comes to mind is 10. You could have done 10, can go into 30 3 times, so you have 3x, and 10 goes into 20 2 times, so you have 2y. So we came up with 3 different ones, but you were supposed to come up with 2. Hopefully you came up with one of these 3, or 2 of these 3. Okay, let's take a look at the 11. Again, pause the video, see if you can come up with 2 more expressions that go with this problem, 15x plus 40y. Remember, you're coming up with a common factor that they both can use. Now pause the video. Okay, now let's think about a common factor they both have. The first one that comes to mind is 5. You could use 5. So I'm going to pull out 5. 5 goes into 15 3 times, so you have 3x, and 5 goes into 40 8 times, so you have 8y. The only other one that comes to mind that can go into both of them would only be 1, which is kind of strange to use 1, but that's the only other one we can do. So we're going to pull out 1. 1 goes into 15 times, so we have 15x, and 1 goes into 40 times, so we have 40y. And that's the only other one you can do. All right, now we're going to do the back side of the page. But before we do the back side, I'm going to ask you a question to see if you watched this video tonight. My famous question is going to be, what was my favorite song that I picked out to be my walk-up song during morning meeting with Mr. Moses in the beginning of the year? You have to tell me when you walk in the door tomorrow. Let's see if you'll know it. All right, now we're on the back. Combining like terms. We have constant terms. It's a mathematical term containing a constant value, a number with no variable. Underline a number with no variable. Then we have a variable term. It's a mathematical term containing one or more variables. Underline one or more variables. Last, we have like terms. Mathematical term that contains identical variable combinations. So, you can combine x terms with x terms and y terms with y terms. And an example, z terms with z terms. So if I combine the 3x with the 6x, you should get a total of 9x in your answer. Then you combine your y's. 7y combined with 3y and 4y. When you add those together, you get 14y. Last, we're going to combine our z's. We have 4z and 2z. When I put those together, I get 6z. So combined the like terms to get a total of each like term. Now we're going to simplify. We're going to combine the like terms. The like terms I see together in number 12 are y. There's only y. So I only need to combine the y plus the y plus the y. They're all the same. They're constant terms. Okay, so when I put those together, I should get a total of 3y. Look at number 13. Now I have some more constant terms. I have 2x's plus the 1x, which counts as just 1x, plus 4x's. 1, 2, 3, 4. How many total x's do I have? 1, 2, 3, 4, 5, 6, and 7. 7x. Look at number 14. Now I have some variable terms. I have z's, y's, and x's. Let's start with putting our z's together. I have 2z and 3z. When I put those together, I get 5z. Then I don't have any like terms that go with y, so I'm just going to put the plus 4y. And poor z, or x, sorry, he doesn't have any like terms. So I'm just going to put plus